Hello, statistics student. This video is for chapter 2.7, part 2. In part 1, we were talking about the two summary that we can use to measure variation of data within a data set, and the two range as well as standard deviation. We spent a lot of time on how to calculate standard deviation and what is the meaning of a standard deviation. So we did one by hand and then we did one with StatDisk. And so we were working on the example 3 where we have a grouped data of frequency distribution and we want to find the grouped standard deviation. So how do they spread out? We have entered this into StatDisk in a show the editor. So we generate the data by using the frequency table generator. And now we are going to calculate it. So 2, right? So the data is here. And we find the mean is 84.5 last time. And then standard deviation is right here, S, 12.06. That means 12.1. 12.1. So go back to the paper and put in 12.06 or 12.1. Usually we round it to one decimal place. And then continue with the topics. The third one that we can use for measuring variation is called IQR. So IQR you have encountered before when we are talking about how to identify something being an outliers. So IQR is useful because 1.5 times beyond Q1 and Q3 is an IQR. But because it measures spread of the data, the IQR itself, which is the middle 50% spread of data, is a good measure of variation. So it's the middle 50% range of data. So we use it to describe variation. Okay, so and then this particular one is not very popular actually, but it is useful because it is resistant to extreme data. So just do an example. I have A, which is 563,268, the one that we have last time, this list of data. And then I have one that is 60, really far away. So if we do go to StatDisk, I think the column 1 has this data. So this, if I evaluate column 1, the IQR is Q3 minus Q1, which is 10 minus 5 is 5, right? For the original one. So if I add a 60 into it, all of a sudden there is an extreme data. I evaluate again. So you can see that Q3 minus, did I do that? Yeah. Let's just do it. Enter it. Oh, yes. And then evaluate again for 1. Right, so earlier it did not. So Q1 is 5, Q3 is 12. So it does not affect the middle 50% that much. It's 7. So increase a little bit only instead of like if you look at standard deviation, the standard deviation becomes 17 versus in the past it was much lower. I think it was 6, was it? It was 6 something. Yeah, it was 12.06 and now become 17.1. So it's much large. It's a little bit larger, I would say. So so it is IQR is a measure of variation. It's a certain measure of variation. So this 3-number range, standard deviation, IQR, out of the 3, standard deviation is still very popular. Okay, so there is other measure that's related to variation. We don't particularly use it to do to compare variation, but they are there. The first, of course, is population standard deviation. So the whole point of finding S is this describe how data vary in a sample is we can use it to estimate the population standard deviation. Now it has a different formula as well as a different symbol. Sample standard deviation symbol is S, right? for sample standard deviation. Population standard deviation is sigma. See, it is a Greek letter, and the way you pronounce it is sigma. And the way you write it, because it's a Greek letter, is like you spell work O, like that. Okay, so sigma is, how do you calculate it? It's x minus mu. It's the difference of each data from the population mean, mu, square it, add all of them together, divide by n. Instead of n minus 1, it's divided by n, and then do square root. So you do not divide by n minus 1. So they have different formula as well as different symbol. So of course, we would use, of course, we would like to use S, can estimate, can use a sample, can estimate sigma, right? So how do I find population standard deviation? Of course, you have to have your population data. If you do a census, you collect everyone's data in your population, you can use this formula to calculate it. Now, StatDis does not provide that, because StatDis assume that most of the data that you had were actually 99% of the time, except for the Census Bureau, I guess. All the data that you have are just sample, right? You use S to estimate sigma. So no one actually are in the business of needing to calculate population standard deviation. So they don't have it. They don't have it in when you are doing the descriptive statistics. So you see they have mean, median, mid-range. I don't know what RMS is. Variance, which we'll talk about, standard deviation, but there's no population standard deviation. So how do I do the population standard deviation? We would look at another calculator called social science calculator, which you have used before, social science statistic calculator. So what you do is you click on it and then you say descriptive statistic, you want variance and standard deviation. And then you put your stuff in it, you put your data in it. So in our case, we have the video data is 5, 6, this one. So let's try. Just assume that this is my population data. I put it in and I say that these are population. You have to tell them. And then you do calculate. It would give you, they actually show you the step. It gives you sigma square and sigma. Okay, sigma square and sigma. Sigma is the population standard deviation. And of course, it's not very good because of tons of add. So we call it sigma. So the other the other measures that are related to measure of variation is variance. Now, variance is actually a number that is before you take square root when you're doing calculation of standard deviation. So it would be sigma square as well as S square. So sigma square is the population standard deviation square. That means before you do square root. S square is from sample standard deviation. So they do not have their own symbol. They just use sigma square and S square. It's called variance. What are they used for? They are used for statistical analysis. By the time we hit chapter 5, you understand why we need this too. Okay, so they are there for statistical analysis, not for measuring variation. So before we go into something called C-score, I'm going to do some examples on, finding standard deviation, and also for you to understand what is the use of standard deviations. So the main use of standard deviation is if I have some data, I put my data in a number line as if I'm doing a dot plot. The importance of standard deviation is, so if like a dot plot, so I have all my data like around this, they scatter around, right? So these are my data. So what happened is, of course, the middle is the mean, right? This is X bar. What happened is you can use standard deviation as a ruler, and if this is one standard deviation, instead of using the common number line tick mark, a standard deviation is one tick mark. And then This is 2 standard deviation above. Well, one more. This is one more standard deviation below. This is another standard deviation below. It turns out that most of the data, 95% of the data, are within 2 standard deviation above or below. So you can kind of use the standard deviation as a tick mark to say, well, how does my data spread? You can get a feeling as to I should not have anything that is over 2 standard deviation away from the mean. So it is a measure of how data spread by using the standard deviation as a tick mark. And you should have 2 tick mark on the left, 2 tick mark on the right. Okay. So we give a tick mark, one tick mark as a C-score. Okay. So, but we'll talk about those later. Let's do some calculation here in this side. Example 2. So we have some fifth graders scores. Ages, not scores. Ages of 25th graders are given below. We want to find the mean and standard deviation of ages. So although they are the same grade, they're all fifth grade, but they do have different age. So from 9 years old to 11. So let's, do I have those in my data set? Yeah, I have the age here. So I'm going to copy it. And then I'm going to put it in the stat this to calculate. So put it in column 3 and then use this to do column 3, explore data. And my mean is 10.5. Write this down. My standard deviation is right here is 0.7. We just use 1 decimal. Oh no, we should do 2 decimal because the data has 1 decimal. 10.53. 7.72 standard deviation. Mean standard deviation. What is the range? Do I have the range? Range is 2.5. The variance is 0.5125. So these are things that usually people will ask. So let's go back to the page. So for the mean and standard deviation, the mean would be you would say the mean is 10.53. Standard deviation, I will use the symbol S equal 0.72. Okay, what age is 1 standard deviation above the mean? So you can think of it as, I have a 10.53 here. What is 1 tick mark and another tick mark? You do not use 11 or 10.5. You use the mean and the standard deviation as your tick mark. What is 1 above it? So it would be 10.53 plus 1 times of 0.72, right? So in a scientific calculator, 10.53 plus 0.72, that would be, 10.53 plus 0.72 is 11.25. So someone's age is 11.25. That is 1 standard deviation up from it. What age is 2 standard deviation below the mean? So I would do a 2 tick mark below on this and this. So minus 10.53 minus 2 times of 0.72. So use a calculator. 10.53 minus 2 times 0.72. That's 9.09. So this tick mark is 9.09. You can find this also by subtracting 0.72. Now, if we know these tick marks, then we say they ask how many data are 2 standard deviation below the mean or 2 standard deviation above the mean. We know 9.09 is 2 standard deviation below the mean. What about 2 standard deviation above? So what we can do is 11.25 add 0.72 one more time, 11.97. Right? So that's 11.97. This is 9.09. This is 2 tick mark. So now our tick mark are not 0.5 or 1, but one standard deviation, one standard deviation, one standard deviation, one standard deviation. So the